All right, today we are going to finally be starting Chapter 9. We are in Lesson 9.1.1 called Solving Quadratic Equations. So let's start to recall what we did in Chapter 8. If we were asked to find the x-intercepts of a parabola that is given in y equals ax squared plus bx plus c form, I want you to think about how you would approach this. So the first step when you see x-intercepts is hopefully everyone by now is remembering y equals 0. So if we want to reword the question, we can word it as, how would you solve something as 0 equals ax squared plus bx plus c? When this standard form equation is set equal to 0, we can't try to start just moving things around. That is the trap that some of us want to fall into. But rather, you should look at this and say, I need to get this standard form into factored form. So first, I need to rewrite the expression in factored form. Now, how do you rewrite a standard expression in factored form? We utilize the diamond and rectangle. Okay, so we're going back before we learned about completing the square. Now, once the equation is in factored form, then what can we do? We can go ahead and we can utilize what we call zero product property, ZPP. And that is where we have each factor set equal to 0 and we solve what we call mini equations. So kind of getting your mind back on track of using factoring, we are going to look at question 1, which tells us to use the zero product property to solve the quadratic equations below. Now, notice all of these are considered equations rather than functions because they are set equal to numbers rather than variables. All right, so in order to use ZPP to solve an equation, the first thing we have to have is we have to have the equation set equal to 0. If it's not set equal to 0, you need to get it equal to 0. And the second thing that we must have is the equation must be in factored form. So if you glance down at number 1, that is certainly not in factored form, so it's going to take some work. So at this point in time, I think some of you can pause the video and go ahead and try to solve these 3 problems, and then go ahead and play it through and see if you took the correct approach. If you're still not feeling confident, keep me rolling. So the first step that we have to see in number 1, which is 9 equals 3x squared plus 4x minus 6, is it's not set equal to 0. So we need to go ahead and subtract 9 from both sides so that now we're working with an equation 0 equals 3x squared plus 4x, and then negative 6 minus 9 is negative 15. So now we can look at this and see that it's set equal to 0. So the next step that we have to do is we have to get the right-hand side in factored form. So let's go ahead and recall that factored form uses a rectangle paired with a diamond. Okay, so now this is where things might get confusing because we just drilled completing the square for 2 or 3 days. So now we're going to go ahead and place our x squared tiles along with our unit tiles, and we're going to multiply up the mountain and put the product at the top of the diamond. We are going to place our x terms at the bottom of the diamond and think about numbers that multiply to be negative 45. So we know one has to be negative, one has to be positive, but add to be 4x. So I think that we are going to have to use 9x and negative 5x. Because in this case, we're really thinking about subtraction. 9 minus 5 is 4. So we have negative 5x, and we have our 9x. And let's go ahead now and look at the GCFs of the rows and the columns. So the GCF of the first row is going to be 3x. And the second row is going to be 5. And then the second column, the bottom row is going to just be plain old x, and then the top is going to be a 3. Now we must consider where we are going to go ahead and put the negative. So we see that the second column has both boxes negative. So there is our rectangle. So now if we rewrite the equation in factored form, we have 3x minus 5 times x plus 3. And now it is time for our mini equations. Okay, so what are our mini equations going to be? We are going to have 3x minus 5 equals 0, and our other mini equation is going to be x plus 3 equals 0. So then these are 1 to 2 step equations. So to solve the first one, I'm going to add 5 divided by 3, so I get x equals 5 over 3. And then my second equation, I'm just going to subtract 3, so I get x equals negative 3. So these are the solutions to equation number 1. So now let's look at equation number 2. It says 0 equals 3 times the quantity x minus 5 times the quantity 2x plus 3. We see that this equation is already in factored form, and we already see that it is set equal to 0. So the two things that we have to check for are already completed. Now we do see this 3 out front, which I call the GCF of the problem. So if you recall, we saw this a few times at the end of chapter 8, and what we can go ahead and do is we can divide both sides by 3. Now, why do I like 0 divided by 3? Because that side on the left-hand side remains 0, but then the 3's cancel out, so we are just getting to consider the quantity x minus 5 times the quantity 2x plus 3 equals 0. Now, from here, we simply branch off into our mini equations. So we were lucky and got to avoid the rectangle diamond because the problem was already in factored form. So please do not try to make the problem harder than it needs to be. So at this point, we're going to add 5 to get x equals 5, and then on this equation, we are going to subtract 3 and divide by 2. And these are our two answers, x equals 5 and x equals negative 3 over 2. Moving right along to the third practice problem, I noticed that there is no C term in this problem. So don't become a robot and jump straight into using a rectangle diamond, but we always want to ask ourselves, is there a GCF in the original standard form before we get ahead of ourselves? So the GCF of x squared and 6x is x. So we can do what I was calling reverse distributing last chapter and factor out that GCF and ask ourselves, x times what is x squared? And then x times what is 6x. So this right here is factored form without even using a rectangle diamond. Again, try to look for the easiest route possible. So at this point, we're in factored form. We are set equal to 0, so we can definitely use ZPP. So we are going to have our first equation as x equals 0, and our second equation as x plus 6 equals 0. So we see the first equation is already solved, and the second equation, we just subtract that 6 over, so there would be our solution. So now what we are going to do is we are going to consider how we can use our calculator to verify the solutions that we just got in 9-1. So what we're going to do is jump on to our graphing calculator or Desmos, and if you recall, problem number 1 was asking us to solve, what was it? If I look back on my note sheet, it was 9 equals 3x squared plus 4x minus 6. So what we are going to do is we are going to enter the right-hand side expression into our y1 in our graphing calculator, and then we're going to think about where on the graph would we look to verify our solutions that we got. Now, if you recall, the solutions that we got on equation 1 were x equals 5/3, and the other solution was x equals negative 3. Okay, so it's just kind of good to remember what we just did. So now I'm going to go ahead and utilize my camera and see if I can show you my graphing calculator screen. Whoops, you're getting a tour of my desk here. Okay, so what we're going to do, I'm just going to go ahead and hold it, so sorry if it's a little bit shaky. Okay, we are going to enter into our y equals, we are going to do 3x squared and then plus 4x, and then we have minus 6 because we're going back to the original equation. Okay, so there is what we have on our graphing, or on our y equals, and then we are going to enter that in, and we are going to go ahead and graph. Now here is a picture of the graph. And the big question is, where can we find our solutions to the equation that is set equal to 9? Well, if you think about it, that 9 is in place where y would normally be on the function. So what we are going to do is we are going to look at the points on the graph when y is 9. So you can look at my mouse right now is pointing to y equals 9. So I'm going to go over and think about what is the x value of that point, and if you kind of look, it seems like it's between 1 and 2 if I look at my tick marks on the x-axis. And then let's look at what is the value of this point here. It looks like it's about at negative 2 or 3. Okay, so now if we go back to our note sheet and we look at the solutions that we got, our first solution said x equals 5 over 3. Well, what is 5 over 3? It is 1.6 repeating. And what did I say that x was approximately at? Between 1 and 2. So again, this is between 1 and 2. And then I said it looked like our other solution when y was 9 was between negative 2 and negative 3, and our solution was exactly negative 3. So where on the graph did we look? On the graph, we looked at the x values when y equaled 9. And that is how you can check from now on the solutions that you get to any given equation. This is in place of y, so that's why we looked at y equals 9. Now the next question says, where in the table would you look on your graphing calculator? Okay, so if I go ahead and go back to our camera and we look at our table, so we are going to go ahead and go to second graph because it says table. Okay, we can look at the y column and we're looking for y equals 9. Well, you can see the numbers are going in ascending order, so we can see that 9 is going to fall between 1 and 14. So if you look at the x values paired with 1 and 14, once again, you see that the x solution is going to be between 1 and 2. And then if we go ahead and go back up, we're going to see numbers going in the reverse direction. We can see actually on the table y is 9 when x is exactly negative 3, and that was one of the solutions we got. So now it's just coming full circle for us. So again, to reiterate, where in the table would you look to verify your solutions to part A? We would look for y equals 9, and then the x value or values is the solution to the equation. Okay, so now we want to go ahead and think about how would we check for the other problems to verify that our solutions were correct for the problems in 9.1. So if you look up on our equations from 9-1, okay, we can see number 2 was set equal to 0, and number 3 was set equal to 0. So if we're trying to verify our solutions, because we see that number 2 was 0 equals, what was it, 3 times x minus 5 times 2x plus 3. Okay, we are going to put this entire quantity into y equals, and then the solutions occur at the x values when y isn't 9, but when y is 0, because again, this 0 controls, okay, where you look for the solution. Well, what is so special about y equals 0? The solutions to this problem are truly the x-intercepts, because we've done this before. We replace we've replaced y with 0. So in this problem on number 2, you would not look at when y equals 9. You would look at that x-intercept to find the solution. And the same thing is going to be true for question number 3 that we just did above, because question number 3 is also set equal to 0. Okay, so now we're going to move on. Don't get too caught up in the graphing calculator, but again, one of my goals is to show you how to become efficient with that tool to check your work in order to progress through problems. So now we are doing a completely new problem, and we are being asked to solve the quadratic equation x squared minus 6x minus 1 equals 0. If you're taking notes on a blank note sheet, I would suggest you can maybe pause to jot down the instructions. It doesn't have to be word for word, but when you look back, you want to remember what we were doing. So the first thing that we need to do is they're suggesting to try to use ZPP. Now, what do we always have to do when we look to use ZPP? We have to figure out a way to get that in your head. So we go back up to the original problem and we see that it is certainly not in factored form. So we need to get it into factored form before we even consider zero product property. So we have x squared, we have -1, we set up our diamond by multiplying up the mountain, -1x squared, and then we have -6x. Well, the only numbers that multiply to be -1 are 1 and -1, and those certainly don't add up to be -6. So what happened? We see that it doesn't factor. So here is where some people get lost. Just because something doesn't factor does not mean you can jump to saying no solution. So just because we wrote doesn't factor, this does not mean no solution. And I want you to write that down. It does not mean no solution. Okay? What are we going to do, though, when something doesn't factor? We have to turn to an alternative method. So because on part B, the quadratic expression did not factor, we must turn to another approach. The only other option that we have is to, what did we work on the past 2 days? Complete the square. We can complete the square to get the equation in graphing form and then think about undoing from the outside in. So let's go ahead and give it a try. Our equation was x squared minus 6x minus 1. X squared minus 6x minus 1 equals 0. So you learned how to complete the square when it was a function, when it was y equals. Guess what? Nothing is going to change when there's a number. So let's go through completing the square. Instead of a y, we're going to place the constant, which in this case happens to be 0. We are going to leave a blank, and then we are going to make our square and we are going to always place our x squared term in the bottom corner. And then we are going to think about negative 6x divided by 2. This is kind of our scratch work, which negative 6x divided by 2 is negative 3x. So we have negative 3x and negative 3x. And then in order to figure out how many we need to add, we know that we currently have negative 1. And then we need to go ahead and calculate negative 3 times negative 3. It's always the outer dimensions of the box. Okay, these are always the same, and they're always established after we place our first L. So we know negative 3 times negative 3 is 9. So we have negative 1. We need to get to 9. So what do we have to add to negative 1? We have to add 10. You always have to start out with what you're given and then think about getting to what you need. That order is important, or else you will make mistakes with the positive and the negative. So what do we have? Now we are not going to write y plus 10. We can certainly do 0 plus 10. So let's go ahead and do that over on the right-hand side. So we have 10 equals, now we completed the square on the rectangle side, so we have x minus 3 quantity squared. Okay, so we are going to treat this just like we did when we solved for x-intercepts when it was in graphing form. Remember when we first moved the constant over after we replaced y with 0? Now, if we're working outside in still, we see that we have to undo the square by taking the square root. So we have plus or minus the square root of 10 equals x plus 3. Now at this point, we have many equations. Okay, we have the square root of 10 equals x plus 3, and then we have the negative square root of 10 equals x plus 3. So we are going to solve these in the same way by subtracting 3. So we have negative 3 plus the square root of 10 equals x. And then we have negative 3 minus the square root of 10 equals x. Okay, now these don't make sense if we were going to go to a graph, so at this point is when we pick up a calculator, no point before this, and we are going to get our approximations. So we are picking up our calculator and doing negative 3 plus the square root of 10, and we get 0.16. Okay, and then from here we are going to do negative 3 minus the square root of 10, and you are going to get negative 6.16. Okay, so together we see that the solutions to the original equation, which is up here, go ahead and use my highlighter, this is our original equation, the solutions occur right here. Now in this next paragraph, they're going to talk to us about the names of those solutions. And we've already previewed this a couple lessons ago. So to make sense of the x-intercepts, we probably wrote the solution as a decimal, which you can see in these two places. Okay, it says square roots that are not perfect squares, which the square root of 10 is not a perfect square, are going to create irrational numbers. Okay, irrational numbers are numbers that cannot be written as fractions or integers. So right now, if you still have your decimal in your calculator, I want you to do math enter, which tries to convert the value into a fraction, and you can see that it does not convert. So not every decimal can be written as a fraction, and those are called irrational numbers. The decimal continues infinitely and will never go into a repeating pattern. When you write a square root as a decimal, we had to round. So we call this approximate form. So I'm going to go ahead and color code. Approximate decimal form is these two answers right here. On the other hand, when we use the square root symbol, that is called exact form, okay? So these solutions right here are considered exact because no rounding took place. We always, always, always will first find the exact form, and then we will use that exact form to pick up our calculator to get the approximate, okay? So in order to find an approximate answer, you have to first find the exact. That's a great rule of thumb. We are almost through the notes. Now it's our turn to try a problem. So if you'd like to pause this and try on your own, I would encourage you to do so. But the question says to use the completing the square method to solve the quadratic equation x squared plus 4x minus 5 equals -2. It wants us to write our answer in exact form. We have to do that first. Whoops, sorry. And then secondly, we will pick up our calculator and write it in approximate form. So, in order to complete the square, we are going to put our units on one side, leave a space, draw our square, and go ahead and place our x squared term, and then we take 4x divided by 2, so 2x on each diagonal, and that defines the dimensions. In this case, it's positive. Whoops, I forgot my equal sign. And from here then, we take our units, which are 2's, and we take 2 times 2, which says we need a total of 4 units. But how many do we have? Right now, we have -5. So it's kind of a puzzle. How do we get from -5 to 4? We have to add +9. So what we do to one side, we have to do to the other side. Now instead of writing y plus 9, we have this -2 here. So we are going to do -2 plus 9, which is 7. And then on the right-hand side, we have our perfect square, which is x plus 2 quantity squared. Now, because we are simply asked to solve, we need to try to get x by itself, and we are going to use undoing from the outside in. So I'm going to undo the square by go ahead and writing plus or minus 7, square root of 7 equals x plus 2. So then at this point we have our mini equations. We have the square root of 7 equals x plus 2. And then we have negative square root of 7 equals x plus 2. So from here, let's go ahead and subtract 2. So we have -2 plus the square root of 7 equals x, and then we have -2 minus the square root of 7 equals x. And then at this point, we can pick up our calculator, and we can do the calculation -2 plus the square root of 7, and we get x is approximately 0.65. And then if we pick up our calculator again and do -2 minus the square root of 7, we get x is approximately -4.65. So let's again kind of debrief what are our exact answers. Okay, these right here are the exact answers in yellow, and then from there we use the exact answers to get the approximate answers. So the approximate answers are written or highlighted in green, just to be clear. Okay, so if you cannot take the square root of a number, that is irrational, and you will have exact and approximate answers in every problem that you do. So the final question is checking using our graphing calculator. So we are going to go ahead and one more time think about, if we have a graphing calculator handy, how are we going to look for the solutions to the equation x squared plus 4x plus minus 5 equals -2? Well, we are going to enter this into our y equals, and then we are going to look at the x values when y equals -2. So let's go ahead and do that one more time. Go to my camera. Okay, and we are going to go back into, sorry, it's a little blurry. Go back into our y equals, and we have to clear out our other problem. And we have x squared plus 4x minus 5. And we are going to press enter. We are going to view the graph. And then again on this graph we are looking for when y is -2. So if I go over to negative, or go down to -2 on the graph, and then I look left and right, okay, I can see that my cursor is over, okay, one of the two solutions, which looks like it's very, very close to x equals 1. What did we get? We got 0.65, which is very close to x equals 1. And then if I move my cursor over to the other value here, okay, it looks like it's very, very close to -1, 2, 3, 4, 5. -5. What did we get? We got -4.65, which is very close to -5. So the moral of the story is the graphing calculator isn't perfect, okay, but you need to kind of start getting used to how to quickly graphing and then just simply estimating if your answer is on the right track. So that does it for our 911 notes. Please go ahead and kind of review these notes, complete the 911 homework, and don't forget to upload your notes and homework to the Google form so that I can give you credit for those. We will talk to you next time.